All right, let me start with something that sounds trivial and then refuses to stay that way. You walk into the bathroom in the morning. You're half awake, your hair is doing something illegal, and there's the mirror. You raise your right hand, and the fellow in the mirror raises his left. Everyone says, of course, mirrors reverse left and right. We say it the way we say, the sun rises in the east, as if that settles it forever. But just stop there for a second, really stop, and ask yourself, why on earth left and right? Because here's the strange part. The mirror doesn't reverse up and down. You don't see your feet where your head ought to be. If mirrors were in the business of reversing directions, they're doing a very selective job. They pick left and right and leave everything else alone. That should bother you. If it doesn't, you're not paying attention yet. Try a little experiment. Don't move your head. Just think. Imagine there's a tiny arrow painted on your chest, pointing straight out from you, perpendicular to your body. When you face the mirror, what happens to that arrow? It points into the mirror. The arrow on the fellow in the mirror points out toward you. That direction, front to back, has clearly flipped. No controversy there. So the mirror definitely reverses something. But it's not left and right, it's front and back. Now comes the paradox. If the mirror flips front and back, why do we swear it flips left and right? Why do your watch and wedding ring jump hands? Why does text look backwards? Why do we have this stubborn, almost emotional certainty that mirrors are left-right traders? This is the point where people usually shrug and say, that's just how mirrors work. That answer should make you suspicious. Nature is rarely that lazy. Let me make it worse. Suppose you had a friend, let's call him Sam, who has never seen a mirror in his life. You stand Sam in front of one for the first time. You say, Sam, what's going on here? Sam might say, well, it looks like another person who's facing me. Perfectly reasonable. You say, yes, but notice when I raise my right hand, he raises his left. Sam might pause and say, no. He raises the hand on the same side of his body as yours. You're the one who's calling it right. And Sam would be right, uncomfortably right, because left and right are not written into the universe the way up and down are. Up is against gravity. Down is with gravity. You can feel them in your bones. Left and right are defined by convention, by how you label your own body. They're relational ideas, not absolute ones. Already the mirror is starting to look less guilty. Here's another way to make your brain itch. Take off your shoe and hold it up to the mirror. Not the sole, hold it sideways. What you see is a shoe that could never be worn by any human being in this universe. It's a left shoe pretending to be a right shoe. You can't rotate it in ordinary space to make it match. You'd have to do something forbidden, like pull it through itself, or turn the universe inside out. That's not just a visual trick. That's geometry waving its arms and saying, pay attention. What the mirror has done is produce a world that agrees with ours in almost every respect except one subtle, devastating way. It's not that it swaps left and right, it creates a version of you that lives in a space with the opposite-handedness. A chiral world, if you like that word. Your mirror twin lives in a universe where clockwise and counterclockwise have traded hats. And yet, here's the part that really hooks you. You don't notice any of that directly. What you notice is that your hair part is wrong, your face isn't quite the way you imagined it, and your letters are backwards. The deep geometric crime is invisible. What you experience is just a little everyday annoyance. Now let's play a game. Imagine you're trying to explain mirrors to a child who keeps asking, why? And you're not allowed to use the word reflection or any diagrams. You'd probably say something like this. Light leaves your face, hits the mirror, and bounces back. Fine. But bounce back how? Like a rubber ball? Straight back where it came from? No, not quite. The mirror doesn't scramble the light. It's incredibly polite. It sends every ray back at the same angle it arrived, as if saying, you go your way, I'll go mine. So the mirror is not actively rearranging you. It's not reaching out and grabbing your left side and dragging it to the right. All it does is reverse one direction, the direction perpendicular to its surface. Everything else stays exactly the same. Then why, after all this, do we keep insisting that left and right are flipped? Because you are cheating and you don't realize you're doing it. To compare yourself with the image in the mirror, you mentally perform a rotation. You imagine turning yourself around to face the same way as the person in the mirror. And here's the trick, when you turn yourself around, you usually rotate around a vertical axis. You spin left to right, like turning on your heels. That operation swaps left and right, but leaves up and down alone. So when you compare the mirror image to this rotated version of yourself, you conclude quite sincerely that the mirror flipped left and right. But the mirror never did that. You did. The mirror just sat there, doing almost nothing, while your brain performed a quiet, acrobatic move and then blamed the glass for the result. Which is, when you think about it, very human. What's delightful about this is that it exposes a little gap between the world and the stories we tell ourselves about the world. We think we're seeing something directly, but we're actually seeing it through layers of habit, language, and unconscious assumptions about how bodies move in space. And once you notice that gap, you can't unsee it. The mirror stops being a household object and starts becoming a philosophical nuisance. It's showing you that, obvious, explanations often sneak in hidden steps, and that the universe will happily let you misunderstand it until you slow down and ask an annoying question. Because now the real trouble begins. If mirrors don't reverse left and right aren't fundamental anyway, then what exactly is being reversed? And why does that single reversal feel so deeply personal, like it's messing with your identity instead of just your geometry? If you want, we can keep going. Good. Then let's keep poking at it, because once you start, it would be rude to stop. Let me ask you to do something very simple, the kind of thing that sounds silly until you actually try it. Stand up if you can and point one finger straight at the mirror. Not left, not right. Straight ahead like you're accusing the mirror of something. Now freeze. That finger has a direction. It's pointing forward away from your chest. The image in the mirror also has a finger pointing. But where is it pointing? It's pointing forward too, from the chest of the mirror person. And yet that forward direction is aimed right back at you. So forward became backward. That's undeniable. Nobody argues with that. But left stayed left, and up stayed up. The mirror didn't touch them. Now try another little experiment, one you can do entirely in your head. Imagine you're holding a book, and on the cover there's a big arrow drawn on it. First, the arrow points up. You hold it in front of the mirror. The arrow still points up. Fine. Now rotate the book so the arrow points to your right. In the mirror, it points to the mirror, person's left. Aha! That's the moment everyone pounces on. See, left, right reversal. But wait, don't let it get away that easily. Rotate the book again. This time so the arrow points toward the mirror. In the mirror, it points toward you. That's the same kind of reversal. So why do we emotionally latch onto left, right, and ignore front, back? Why does one feel like a trick and the other feel like a fact of life? The answer has to do with how we live inside our bodies. You and I spend our entire lives moving forward and backward asymmetrically. We have eyes on the front, not the back. We walk forward, we retreat backward. We shake hands forward. Forward is special. Backward is awkward. So when the mirror flips that axis, we don't register it as a swap so much as a confrontation. The mirror person is facing us, invading our forward space. That reversal feels natural, almost expected. Left and right, on the other hand, are symmetric in daily life. You can turn left or right with equal ease. So when you mentally rotate yourself to match the mirror person, as you automatically do, you pick a rotation that preserves up and down and trades left and right. That's the cheapest move your brain knows how to make. And then, having done that, you accuse the mirror of the crime. It's like blaming the furniture because you tripped while carrying it. Let me give you an analogy that sounds ridiculous but works annoyingly well. Imagine you're wearing a glove on your right hand. Now imagine a perfect glove duplicating machine, science fiction. Of course, that makes an exact copy of the glove but reversed through a mirror. You take out the copy, try to put it on your right hand, it won't fit. You twist it, rotate it, turn it upside down. Nothing works. To make it fit, you'd have to do something impossible in ordinary space, like turn it through a fourth dimension. That glove problem is the same problem as the mirror problem. The mirror doesn't just make a rotated version of the world, it makes a reflected version. Rotation is something you can undo by spinning things around. Reflection is deeper. It changes the handedness of space. Now, here's where it gets fun. Suppose instead of a flat mirror, you had a magical machine that could rotate you, not reflect you, but rotate you 180 degrees around a vertical axis and then show you that image. That image would swap left and right exactly the same way people think mirrors do. But it would also swap front and back. Your nose would now be where the back of your head was. You'd be facing away from the world. That's not what mirrors do. Mirrors don't rotate you. They reflect you. And reflection is not rotation. The fact that we constantly confuse those two tells you something important about human intuition. We're much better at imagining motion than imagining symmetry. So let's lean into that weakness and turn it into a strength. Picture a tiny creature, no arms, no legs, no left or right, just a little dot that can move in 3 dimensions. For that creature, the mirror would not reverse left and right because left and right wouldn't exist yet. The mirror would only reverse one thing, the direction perpendicular to its surface. That's it. No paradox. No confusion. Left and right only appear when you introduce a body with asymmetry, like a human body with a heart on one side and a liver on the other. The mirror isn't messing with the universe. It's messing with your anatomy. You can see this clearly if you stop looking at people and start looking at coordinate systems. Imagine drawing 3 arrows at right angles, one up, down, one left, right, one forward, back. These 3 arrows define space around you. The mirror flips exactly one of them forward, back. The other 2 are untouched. That's the entire story, stripped of drama. But we reintroduce the drama the moment we say, that arrow is my right hand. Because now we've tied a mathematical direction to a personal label. And when the mirror image has a hand in the same mathematical direction but attached to a body facing the other way, the labels clash. The physics is calm. The language panics. There's a famous moment, you can almost feel it when it happens, when people suddenly realize that mirrors don't really reverse left and right at all. They reverse front and back, and left-right confusion is a side effect of how we compare ourselves to the image. When that clicks, it's not just satisfying, it's a little unsettling, because you realize how easily a wrong explanation can feel right if it matches your habits. And that's the real lesson hiding inside this bathroom curiosity. Nature doesn't care how you name directions. It only cares about relationships, angles, distances, symmetries. The mirror follows those rules perfectly. The confusion comes from us insisting that our labels are fundamental. Now, if this were just about mirrors, it would be a neat party trick and nothing more. But the same kind of confusion shows up everywhere, in physics, in time, in causality, even in the way we think about ourselves. We take something relational, something subtle, and we nail a name onto it. Then we forget we did that and start arguing with the universe when it doesn't agree, and mirrors, mischievous things that they are, quietly take advantage of that habit. They don't lie. They don't distort. They just reflect one direction and let us do the rest. But if you're feeling a little too comfortable now, don't worry. There's a deeper layer coming. Because once you start asking why reflections behave the way they do, you're led straight into some of the strangest and most beautiful ideas we have about space itself, and why some differences in the universe are real, while others exist only because of the way we turn around to look at them. All right, now we have to be careful, because this is the point where things can get unnecessarily fancy if you're not watching yourself. And the whole charm of this question, the reason it sticks in people's heads, is that the truth is strange without being complicated. It only becomes complicated when we try to force it into the wrong mental boxes. So let's slow down and look at what a mirror really does, without metaphors for a moment. Imagine a single point on your nose. Light leaves that point and travels outward in all directions. Some of those light rays hit the mirror. When they do, they bounce back in a very precise way, the angle and equals the angle out. That's it. That's the entire rule. No ray ever crosses another ray. No information is scrambled. Every ray keeps its dignity. Now, if you trace those rays backward, as your eyes and brain automatically do, you reconstruct a point that appears to exist behind the mirror, the same distance back as your nose is in front. That reconstructed world looks perfectly normal. Straight lines stay straight, circles stay circles. Distances are preserved, nothing has been twisted or bent, except one thing. The coordinate that points toward the mirror has changed sign. That's the deep truth hiding underneath all the confusion. In mathematical language, which we'll use gently, like a seasoning and not the whole meal, the mirror applies a transformation. It becomes, that's it. No swapping of x and y, no flipping left and right, just a single sign change. Now, here's where intuition starts to wobble. You might think changing a sign doesn't sound like much, but in geometry, changing the sign of one coordinate is a very big deal. It's the difference between a right-handed coordinate system and a left-handed one. And that difference cannot be undone by any rotation in three-dimensional space. You can rotate things all day long, spin them, flip them, tumble them, but you will never turn a right-handed system into a left-handed one using rotations alone. Reflection does something rotation cannot. This is why that glove won't fit. Your right hand is not just a shape. It's a shape embedded in a space with a particular handedness. The mirror image of your right hand is a left hand, not because of labels, but because of geometry. The difference is real. You can feel it in your bones, literally, if you've ever put on the wrong glove. And this is where the mirror stops being just a household object and starts brushing up against fundamental physics. Because it turns out the universe itself cares about handedness. For a long time, Physicists thought it didn't. They assumed that if you took any physical process, throwing a ball, mixing chemicals, planets orbiting stars, and reflected it in a mirror, the laws of physics wouldn't notice. The mirror world would behave exactly like the real one. That assumption is called parity symmetry, and for everyday life it works beautifully. But then, in the 1950s, something astonishing happened. Physicists discovered that certain subatomic processes, weak nuclear interactions, to be precise, do care about left and right. They violate mirror symmetry. The universe, at a deep level, has a preference. It distinguishes between left-handed and right-handed versions of reality. That's shocking if you think about it for more than 5 seconds. It means that if you showed the universe a mirror image of itself, in some cases it would say, "Nope, that's not how I do things." So the mirror problem, which starts with shaving cream and bad hair, ends up touching one of the most profound facts we know about nature. Not all symmetries are real. Now come back to the bathroom with that in mind. When you look in the mirror, you're not just seeing a flip picture. You're seeing a world that is subtly incompatible with ours. A world that agrees with us almost everywhere, but not quite. A world that could never be reached by any continuous motion through ordinary space. That's why the mirror image feels eerie if you stare at it too long. It's familiar, but unreachable. You can wave at it, but you can never shake its hand. And here's another twist that people almost never notice. Writing appears reversed in a mirror, but drawings often don't look wrong in the same way. A simple smiley face looks fine. Why? Because letters are conventions built on left-right distinctions. They encode handedness. A face, at least a cartoon one, often doesn't. The mirror is ruthlessly honest about structure. It exposes which things depend on arbitrary human conventions and which things depend on geometry. Even your own face falls somewhere in between. You think of it as symmetric, but it isn't. One eye is slightly higher. One eyebrow arches differently. One side smiles first. You've just trained yourself to ignore that asymmetry until the mirror throws it back at you in a way you didn't expect. And notice something subtle. Photographs of you often look wrong compared to mirrors. That's because photographs show you the way other people see you, not the way you're used to seeing yourself. The mirror has trained your self-image. It's given you a reflected identity, and when reality disagrees, you blame the camera, which is delightful because it shows how deeply the mirror has crept into your sense of self. At this point, you might be tempted to say, "All right, fine. Mirrors reverse front and back, not left and right. Case closed." But that would be a little premature, because there's still a quiet, uncomfortable question lurking underneath everything we've said. Why is front-back reversal so natural to us that we barely notice it, while left-right reversal feels like a violation? And more dangerously, how many other things do we accept as natural simply because we've built our intuition around them? The mirror has done its job. It's shown us that the way we carve up the world, left, right, forward, backward, is not the way the world is carved. Those divisions are tools, useful ones, powerful ones, but not sacred ones. And once you see that, you start wondering about other divisions we take for granted, past and future. Because in effect, observer and observed, are those built into reality, or are they, like left and right, partly a consequence of how we stand and turn when we look? That's where this is heading. And it's where things stop being just clever and start being a little unsettling in the best possible way.